Hey there, in this video we're going to continue section 2.1. We're going to work on evaluating functions and simplifying the difference quotient. So for our first example, say I have the function let f of x be 5x minus 2. So we want to find some function values. So say I want to find f of 0, f of 3, f of a, f of 2x, and lastly f of x plus h. So f of 0, just as we've done in the previous video, essentially this means when x is 0, find the y value. So you just plug it in. So 5 times 0 minus 2, so I get negative 2. So this will correspond to the point x is 0, y is negative 2, and then you could plot it. What about f of 3? F of 3 would be same thing, 5 times 3 minus 2. 5 times 3 is 15, minus 2 is 13. So what coordinate point will this be? So this would be the point when x is 3, y is 13. And you can see that this is a line, this is a linear function, y-intercept at negative 2 and a slope of 5. So it makes sense that things are increasing pretty fast because the slope is so high. So what about f of a? So here, we're asking to find f of a. So how do I find that? Well, just as we're doing with every time whatever is replaced, the number that replaces x is what we substituted in for x. So in this case, a is replacing x. So I'm going to have 5 times a minus 2. And since we don't know what a is, my expression is just going to be 5a minus 2. And there's not much I can do. So the coordinate point will be x is a and y is 5a minus 2. So this function is a rule that takes the input x, multiplies it by 5, and subtracts 2. So writing in words what the function is doing can help you find when you have things that are not numbers inside. So let's look at the next one, f of 2x. So now I want to find f of 2x. Now remember as we said in words, and I'll write it up here. So what in words this is saying is you take the input, so you multiply the input by 5, and then what do you do? Then subtract 2. So if you say it in words, okay, this function is taking the input, multiplying it by 5, and then subtract 2, then it doesn't matter what you have inside, as long as you remember, okay, so I have my input is 0, so I'm going to multiply it by 5 and subtract 2. My input is 3, I'm going to multiply it by 5 and subtract 2. My input is a, okay, I'm going to multiply it by 5 and subtract 2. So now, here we have the input is 2x, but the function says I'm going to take the input, multiply it by 5, and subtract 2. So this becomes then 10x minus 2. Right? I took the input, the 2x, multiplied it by 5, and subtract 2. And they're not like terms here, so that's as far as I can go. So as a coordinate point, this would look like 2x, 10x minus 2. So the next one is asking us to find f of x plus h. Right, so now this x plus h is the input. So what does the rule say? The rule says we're going to multiply the input by 5, then subtract 2. So for f of x plus h, we're going to take the input, we're going to multiply it by 5 and subtract 2. Right? So that's what the rule is saying. So when you say it in words, it might be helpful to remember what it is that you're doing. So here now I can distribute the 5, get rid of parentheses. I'm going to have 5x plus 5h minus 2. And so this will be my f of x plus h. That will be the answer. Okay, So let's try with a different function. So so another example. I'm going to let f of x be 1 plus 3x minus 2x squared. So same thing, let's try to find a few values. So f of 0, f of -1, what about f of 2? Then we're going to find, let's say, f of 2a, and then f of x plus h. So go ahead and pause the video and try to find these on your own and see what you come up with. And if you want to think of it in words, what is this rule? What is this function saying? So it says you add 1 to 3 times the input, and then you subtract 2 times the input square. So that's one way that you can think of it. Okay, in words, what am I doing? I'm adding 1 to 3 times the input and then subtracting 2 times the input square. So let's try it. For f of 0, I'm adding 1 to 3 times the input and I'm subtracting 2 times the input square. So this I just get 1. For f of -1, same thing. I'm adding 1 to 3 times the input minus 2 times the input square. Now I have to work a little. So I have 1, 3 times a minus 1 is minus 3, and then -1 squared is positive 1, so I just get minus 2. So what does this become? And make sure that you're using your rules, order of operations, right? So you always do it from left to right. So 1 minus 3 is minus 2, and then minus 2 is -4. So that's f of -1. F of 2 is the next one. So f of 2, we add 1 to 3 times the input and subtract 2 times the input square. So this becomes 1 plus 6 minus 2 times 4. So what's that? 7 minus 2 times 4 is 8. So 7 minus 8 is -1. Make sure you follow your order of operations, do things from left to right. The next one is f of 2a and then f of x plus h. So f of 2a, I do 1 plus 3 times the input minus 2 times the input square. And so as things get more complicated, we have to do a little more work. So here I have an a, but 3 times 2 is 6, so I have 6a minus 2 times, I have to square this. So this 2 squared is 4 and a squared is a squared. So I have 1 plus 6a minus 2 times 4 is 8, 8a squared. And there are no like terms, so that's as far as we can go. And now the f of x plus h. So f of x plus h. So now this is our input, right? X plus h is the input. That whole quantity. So this is where I think saying it in words is helpful. So what do? 1 plus 3 times the input minus 2 times the input square. And the input is x plus h. And so what does this become? 1 plus 3, distribute the 3 in. So 3x plus 3h minus 2 times, remember, order of operations, so we have to do exponents. So one technically parentheses first, but the x and the h are not like terms. And here when we say parentheses first means the inside of the parentheses. Notice that I can't bring this 2 in because I will have to do the exponent first. So parentheses, inside the parentheses, there's nothing to do. X and h are not like terms. So order of operations then tells me, okay, parentheses, then exponents. So now we're going to do the exponents. So x plus h squared means x plus h times x plus h. So I'm going to do it on the side here. X plus h times x plus h is x squared plus, what's this, xh plus another xh, so 2xh plus h squared. And so we're going to have 1 plus 3x plus 3h minus 2 times this whole thing, x squared plus 2xh plus h squared. And now distribute that minus 2. So I have 1 plus 3x plus 3h minus, distribute the 2x squared. Sorry, the minus 2. Make sure you take the negative with you. Minus, so negative 2 times the 2xh becomes minus 4xh, and then minus 2 times h squared is minus 2h squared. And now you look for like terms. Do we have any like terms? Does not look like it. So this will be as far as you can go. And so when we talk about the difference quotient, so one of the things you might be asked to do is to simplify f of x plus h minus f of x all over h. And this quantity is called the difference quotient. And it's really the slope of a line. So if you have a function, any function, f of x, and I have the point x here, and then I have some other point, x plus h, then this is x f of x, and this point over here is x plus h, f of x plus h, right, the x and the y value. And so the line, notice that there's a line that connects those 2 points. So if I wanted to find the slope of this line, is y2 minus y1 over x2 minus x1 using our slope formula. And so notice when you do this, the slope is the y value, so f of x plus h minus y1 f of x over the difference in the x's, right? x2 is x plus h minus x1, which is x. And these x's cancel, leaving you with just h. So that's the difference quotient. So the difference quotient is the slope of the line that connects the point x plus h. So back to that problem that we had above, I'm going to do it for f of x equals when we had 5x minus 2. Right above we had f of x plus h was, we said 5 times the input minus 2. So this was 5x plus 5h minus 2. So if I wanted to simplify the difference quotient for this, I have to do f of x plus h minus f of x all over h. So in this particular case, I'm going to have my f of x plus h is this thing, right? So f of x plus h is going to get substituted with 5x plus 5h minus 2, and then minus f of x. F of x is the original function, 5x minus 2. I'm a big fan of parentheses or brackets so that I don't get mixed up, so that I don't forget to distribute my negatives. So simplifying this, you get 5x plus 5h minus 2, and this is why I use parentheses, minus 5x minus the minus 2 becomes plus 2, all over h, and then collect like terms. So 5x and the negative 5x, those actually cancel. 5h, there's no other h, negative 2 and a positive 2, those actually cancel. So I'm left with 5h over h, and now h divided by h is equal to 1. So I'm just left with 5. Now for my other one, for the other function, it becomes a little bit harder. And f of x plus h minus f of x for h4, the function that we had 1 plus 3x minus 2x squared, this is a little bit more involved. And so let's go back up to the top and see what did we have for f of x plus h. And that was the one that we didn't quite simplify because there weren't any like terms. So it was this whole thing, 1 plus 3x plus 3h. I'll write that over here, or you could recalculate it. 1 plus 3x plus 3h, and then we had minus 2, all this stuff, minus 2x squared minus 4xh minus 2h squared. So we had minus 2x squared minus 4xh minus 2h squared. So that was just our f of x plus h. So putting it together, let me just write down, and f of x is our original function, so 1 plus 3x minus 2x squared. So putting it together into the difference quotient, we're going to have f of x plus h, so this whole thing, so 1 plus 3x plus 3h minus 2x squared minus 4xh minus 2h squared minus f of x. Right? F of x is this whole thing. So because I have 3 terms, I'm going to make sure that I use parentheses because I don't want to forget to distribute this negative on the outside. So plus 3x minus 2x squared. And the whole thing is divided by h. Now in the difference quotient, the goal is to get rid of this h at the bottom. Just like we, on the previous one, we got 5 by canceling out that h. Our goal is to cancel out that h on the bottom. Okay, so 1 plus 3x plus 3h minus 2x squared minus 4xh minus 2h squared. And now distribute this negative. So I get minus 1 minus 3x plus 2x squared. And remember, our goal is to cancel this h, so check this out. This is pretty cool. Combine like terms. But as we start to combine like terms, I have my constants, so 1 and negative 1. Those are going to cancel out. 3x, so I'm looking for another x, and it's minus 3x, so those are going to cancel out. And then 3h, I don't have another, just h. Negative 2x squared plus 2x squared, so those cancel out. And which is quite nice. So what are we left with? 3h minus 4xh minus 2h squared. The whole thing divided by h. And what do we have on the numerator? Notice that everything in the numerator has an h. So that means we can factor the h out. So I'm left with 3 minus 4x minus 2h all over h. And there it is. Our goal was to cancel that h. So h divided by h equals 1. And our final answer is 3 minus 4x minus 2h for the difference quotient. So the difference quotient is something that's going to come up quite a bit. To simplify it, and to simplify it, the goal is to cancel this h on the bottom, the original h that shows up in your difference quotient. And again, just to go back up to the top, the difference quotient is really giving you the rate of change of the function between 2 points. So it's the slope of a line that connects 2 points on your function. And so like if x was 5 and h was 1, this will be the point, the rate of change from 5 to 6. How is the function changing? But we will talk more about that as we get further in. Right now, we're just going to practice getting really good at simplifying this difference quotient.